Now we will see how an equivalent circuit of PV cell can be analyzed. So as we already know, PV cell has a junction. PV cell has a junction and it has a circuit, and that circuit is connected to external load. And this PV cell circuit can be written as an electrical circuit as shown now. So the whole PV cell is represented as a diode, and it is connected to external load. This external load has some resistance, that is RL, and there will be two more resistance. One is shunt resistance, that is the resistance because of the cell itself, that is because of the PV cell, and this is RSH, and there is one more resistance, that is circuit resistance, that is internal resistance, that is called RSH, sorry, that is RS. Now this circuit has a current source, that is because of the PV cell. We can represent that as a current source, that is ISC. So this is the current source ISC, which allows the current to pass through the circuit, and this is a series resistance. This is internal shunt resistance. This is internal shunt resistance, and this is a current which flows, a minimum current of IJ also flows through the diode, and that IJ is called as PN junction. It is a junction current. It is known as junction current, IJ for junction current, and this flows through the PN junction. So this diode represents the PN junction, and ISH is a current that flows through the internal shunt resistant. So that we represent the circuit as a resistance. So there will be some resistance offered by the circuit to the flow. In this circuit there will be some resistance offered by the circuit to flow. One is because of the load, and other is the circuit itself has some resistance which is connected in series, like wire resistance, or say some measuring device resistance, something series resistance. RSH is the internal resistance because of the junction, PN junction. That is just represented as a equivalent circuit. And next we see I is the current that passes through the load resistance RL. So I is the current which flows through the external load resistance R load, and here this current flows through the R load, which has a voltage across it. That voltage is V. So this resistance, when current flows through this resistance, it will have a I current I value, I units, and V volts, some V volts, and usually this resistance is very high, shunt resistance is very high, that is why current flows in the load, that is why current flows in the load. Now we have current and voltage at the load. There should be a relation, right? So there should be some relation which expresses how current and voltage are uh, interconnected by mathematical some formulas. And here um, uh, at constant temperature, at constant solar radiation, at constant temperature and solar radiation, we can see uh, the relation between I and V is I is equal to ISC minus I naught exponential of EV by constant KT minus 1. So this is the relation between the current I and voltage V. So this is how current and voltage are related. Then what are these terms I naught, ISC? So these are terms I will just explain you now. I naught is reverse saturation current. I naught is reverse saturation current, or it is also called as dark current. This is I naught. And E is charge of an electron. E is charge of an electron, and that is nothing but there is some value 1.602 into 10 power minus 19 joule per volt is the charge of an electron. And K is the Boltzmann constant. And that value is 1.381 into 10 power minus 23 joules per Kelvin. Next we have T, that is nothing but temperature in absolute scale. T is absolute temperature. T is the absolute temperature in Kelvin. And ISC is nothing but short circuit current. ISC is short circuit current. So last video we have discussed about this power graph. I guess you remember the topic. So this is VOC and this is ISC. Then there is a power curve, Pmax. So all these things we have discussed in the last video. So ISC is short circuit current and this is open circuit voltage, VOC. So here we see VOC, that is open circuit voltage, and for open circuit voltage VOC we have current I is equal to 0. So this is voltage V and this is I current is equal to 0. So if we substitute that boundary condition, we substitute that boundary condition. I is equal to 0, V is equal to Vc. Then this equation can be written as 0 is equal to Isc minus I naught exponential of E into VOC divided by KT minus 1. So I have just replaced this and this. Next, if we have to find out VOC here, the equation becomes, just rearrange KT into ln Isc by I naught plus 1. So this is one equation, this is one equation. Then next, so now we know the equation for power P is equal to voltage into current Vi. So if we substitute that I value, Isc minus I naught, then exponential EV by KT minus 1, exponential of EV minus KT by 1. This into voltage V. So this into voltage V. So what we get now is the equation for power. Now this power in the curve, this is the power curve, variation along voltage. But if you see, if you want to find out P max, you need to differentiate the equation with respect to V and equate it to 0. After all the process, the equation what we get is E, this is for your reference, KT exponential Vm by KT. You can try doing this and check once. So you should get this I naught. So this is the equation for maximum power at the point shown here. Then the voltage Vm, the voltage Vm is the voltage at which we will get the maximum power. So this is the Vm. So this is the maximum power equation. So this will give the maximum power equation. Actually we will be able to find out Vm here. This is the equation to find out Vm. So to find out maximum power, we need maximum voltage. So this is the equation for maximum voltage. Vm is the variable which we will get after solving this, and you have to find out Vm by trial and error. trial and error method. And then we need IM. IM is the maximum current at maximum power point. So at this point there will be IM. So we need to find out IM. For that, substitute this equation. Substitute equation. Say this is equation 2. Let us take this as equation 2. So if this is equation 2, then equation 1 is, this is equation 1. We'll take this as equation 1. So substitute equation 2 in equation 1. So after substituting the equation 2 in equation 1, we should be able to get IM as EVM by KT divided by 1 plus EVM by KT ISC plus I naught. So if you have IM, then maximum power PM is equal to EV square VM square divided by KT, and then 1 plus EVM divided by KT and ISC plus I naught. So this is the equation for maximum power.